today we're going to be looking at properties of exponents. So the first thing we want to do is know what an exponent is. So the larger number, which is x over here, we call that our base. And the smaller number that is off to the corner of the base, that is your exponent. So there are several rules we have to follow. The first rule is a product rule. So anytime you're multiplying two numbers with the same base, you're going to add the exponents. So here we have the same base of a, we're going to add m plus n. So let's do some of these problems. So we have 5 squared times 5 to the 6th power. We rewrite our base, which is 5, and then we add our exponents. 2 plus 6 is 8, so 5 to the 8th power. Now we have y to the 4th times y cubed times y. We're combining all the exponents that have the same base of y. So we rewrite our base and add the exponents. 4 plus 3 plus our invisible 1 there gives us 8. Now we have 7 y to the 5th times 6y. You are going to multiply your whole numbers, your coefficients first. 7 times 6 is 42. And now we can combine our same bases. So we have here y to the 5th, and y. Y to the 5th times y gives us y to the 6th. Our last one here, multiply your coefficients here. Negative 3 times 15 gives us a negative, let's try that again, negative 3 times 5 gives you a negative 15. And then we can combine. We have x squared and x. So 2 plus that invisible 1. 2 plus 1 is 3, so we have x to the 3rd. Then we have y's. Y to the 7th times y to the 6th. So keep the base of y. 7 plus 6 is 13. Now let's look at the quotient rule. So when you're dividing two numbers with the same base, you're going to subtract the exponents. So you keep the same base and you subtract your two exponents. So we have y to the 6th divided by y. We have that invisible exponent of 1. 6 minus 1 is 5, so our answer is y to the 5th. 6 to the 13th divided by 6 squared. 13 minus 2 is 11, so we have 6 to the 11th power. Okay, the next one here. We are going to simplify our coefficients first. So here we have 10 and 15. We can divide 5 out of both of those. So we get 2 in the numerator and 3 in the denominator. Now let's take a look at our a's. We have a to the 7th and a to the 5th. 7 minus 5 is 2. So we get a squared. Then we have b to the 9th over b to the 9th. 9, anytime you have the same thing on top and bottom, they cancel out. So we're just left with 2a squared divided by 3. The next rule is the zero exponent rule. So anytime you have an exponent of 0, no matter what it is, the answer is going to be 1. So this whole parenthesis of negative 3x plus 7 is raised to the 0 power. So this whole answer is 1. Now we have 8x to the 0 plus 5. Our x to the 0 is equal to 1. But we still have everything else. So now we just have to simplify. 8 times 1 is 8. 8 plus 5 gives us 13. Now let's look at our last rule, the negative exponent rule. So you can never have an answer with a negative exponent. So you have to rewrite the power with a positive exponent after you move it to the numerator or the denominator. So it's always the opposite position that it's located. So we have 2 to the negative third. Change this into a fraction. Put it over 1. 2 to the negative third is located in the numerator. So we are going to move him to the denominator. So we can make it a positive exponent. So when we move him, he becomes positive. So 2 to the positive third. There's nothing in the numerator, so we're going to put a placeholder of 1. And now we can simplify this. 2 to the third is 8. So our answer is 1/8. Let's look at the next one. Negative 3 to the negative third. So make it into a fraction if it's not already. Circle what has a negative exponent. So negative 3 has a negative exponent, so we're going to move him to the denominator to make it a positive exponent. So negative 3 to the positive third. We need a placeholder at the top, and then we can simplify. Negative 3 to the third is a negative 27, placeholder of a 1 on top. Let's look at the next example. 1 over 5a to the third. It's a fraction. Now find what is negative. A to the negative third is the only thing that's negative exponent. So we're going to move just the a to the numerator. The 5 stays put. When we move the a to the numerator, the exponent becomes a positive 3, and then we have to bring over our 5. Our last problem here, we have negative 3 times y to the negative 7th, all over x squared y to the negative 2nd. Circle your negative exponent. So we have y to the negative 7. We're going to move him down. We have y to the negative 2nd. We're going to move him up. Everything else stays put. So negative 3 stays put. X squared stays put. Y to the negative 7, we move him down, and he becomes positive 7. Y to the negative 2nd, we move him up, becomes y to the positive 2nd. Now, we still have y's that have the same base here. We have y squared divided by y to the 7th. We need to simplify that, so we're going to subtract. Take the larger exponent, 7, and subtract 2 from it. To get y to the 5th. We're going to put y to the 5th on the bottom because 7 is larger than 2. So y to the 5th. and then bring down everything else in the same spot. So that is the first part of the properties of exponents. Please reach out if you have any questions.